Hi, welcome back to Kindergarten Diamond 5. Today we're going to talk about geometric reasoning and we're going to focus in on those three-dimensional figures. My name is Bailey Murphy and I'm a math DRT. So before we get started, I want you to do this first task. You're going to pause the video in just a moment. You're going to complete the task on your own or with a team or partner. And while you're completing the task, I want you to be thinking about what does student learning need to look like in order for your students to be successful with each of these tasks. I also want you to consider what are some misconceptions that your students might have and think about how we're going to be able to address those in our instruction. So here are your two tasks. Go ahead and pause the video and we'll see you back in just a minute. Welcome back. Let's take a look at the progression with BEST for this unit. In kindergarten, students are expected to be able to identify 3D figures, and that's limited to spheres, cubes, cones, and cylinders. And that's going to be regardless of their size or their orientation. Students in kindergarten will also compare and sort 3D figures based on similarities, differences, as well as relative positions. And they'll also be expected to find real-world objects that can be modeled using those 3D figures. This learning will continue on in first grade, where students will be then expected to identify, compare, and sort 3D figures, and that includes all of the shapes from kindergarten, plus rectangular prisms. Students in first grade will also have to compose and decompose 3D figures, as well as identify 3D figures modeled in real-world objects. In this video, we're going to focus on the kindergarten benchmarks of identifying and comparing and sorting 3D figures. So, like all kindergarten units, we want to really focus on those concrete models and to make sure that students have a strong foundational understanding of three-dimensional figures. So throughout this unit, we want to use a lot of different types of concrete models to help students understand the difference between defining attributes and non-defining attributes and how those attributes can actually be used to identify the shapes. So you can see on the screen, I have a variety of 3D shapes that look different, but they have the same defining attributes, and we can help students understand how some of these are the same shape, but they might be a smaller size, they might be a different color, and that's okay, they're still the same shape. At the beginning of this unit, students should be given a lot of opportunities to sort 3D shapes, and this should be done with a lot of different sizes and colors and different types of concrete models, as well as even pictures and representation. When students are using those concrete models, they can physically touch the shape and begin to understand the defining attributes. So take a look at the shapes on your screen, and I want you to think about how a student might sort these. When students first start sorting, they might be tempted to sort by, is it a hollow shape? Is it filled in? Is it black? Is it white? Is it small or large? And those are non-defining attributes, and we want to help students understand that even though one of those cones is filled in and the other cone is not, those are still cones because they have the same defining attributes. So some of the different ways that our students might sort is by, does the shape roll or not roll? Does it have squares, circles, or triangles? Points or no points? Straight or not straight? It's the same shape, the number of vertices, the number of faces, and even the number of edges on the shape. Once students can sort those 3D figures by defining attributes, they can then use those attributes to actually identify the 3D figures. So students should be exposed to different types of spheres, cubes, and cones and cylinders in kindergarten, and they should have different sizes, different orientations, as well as the relative position. So when we're thinking about the different sizes, students are going to think that because the cube is smaller, it's not a cube. However, if we go back to those defining attributes, we know that it has square faces, the same number of faces and same number of edges. When I think about orientation, we're really thinking about the placement of the shape in the direction that it's facing. So if I turn a shape on its side or I turn it all the way around, it's still the same shape, has the same defining attributes. When we're considering what relative position means, this is where students should be able to describe where the shape is in comparison to something else. So they could use some of the words like the shape is above, it's beside, below, in front of, next to, behind, and under. So as students work with sorting and identifying 3D shapes by defining attributes, they can then actually start to sort these 3D figures based on the defining attributes. So some of the defining attributes could include edges, the number of vertex, the number of faces, as well as the shape of the face, the apex or the point of the cone, as well as the base. So I want you to take a look at these two groups of shapes and think about how were these shapes sorted. So these shapes were sorted by the type of face shape they have. So one side has circular faces while the other one has a square or rectangle face. If you think back to the task that you did at the beginning of this video where students were asked to sort these shapes by the same number of faces, this would be the point in time where we would expect students to be able to explain what does face mean for a 3D shape and how can we count the number of faces, as well as how can we sort these shapes by the number of faces. Within this unit, students will be expected to use those defining attributes to model 3D figures that are found in real-world objects. If you take a look at the screen, I have a variety of images of real-world objects, and students would be expected to identify which 3D figure was being modeled. If we think back to that task at the beginning of the video, where students were expected to look at the picture of these two real-world objects and determine how these figures were similar and different, as well as identifying which one's the cone and which one's the cylinder. We know that the figures are similar if we think about our defining attributes because they both have a circular face. However, they're different because of that defining attributes of the cone having that apex or that point, and the cylinder has two circular faces. So we know they're different, and I'm also able to use those defining features to identify the cone as well as the cylinder. As we think about the CRA model with this unit, we know that our kindergarten students need to spend a lot of time in this concrete thinking stage where they're physically touching the shapes and understanding the difference between defining and non-defining attributes. Students in kindergarten are expected also to be able to look at representations or pictures of shapes as well as pictures of 3D figures to identify what those 3D figures are. Students can move through this, and as they start to really get a solid understanding of what defining attributes are and how they're related to the 3D shape, they could use this abstract thinking. So for example, I know this shape is a sphere because it has no faces, edges, and it rolls. It's important to remember that students should be moving back and forth between all three of these stages to make sure that those bridges between the concrete and representation and the representation and abstract thinking is really strong. Thanks so much for watching today. Talk about kindergarten and three-dimensional figures. We'll see you next time for the next dive.